The Italian astronomer Galileo once wrote that the great book of the universe stands continually open to our gaze. But it cannot be understood unless one first learns to comprehend the language in which it is written. Throughout the centuries, we have turned our eyes to the heavens in an effort to fathom their complexity, meaning, and design. It is a timeless quest for discovery, and today it is enhanced by the most sophisticated instruments ever devised. Amazing tools of astronomy that draw the deepest regions of space into clearer focus than at any time in history, unfolding before our eyes a vast frontier of seemingly infinite wonder and size. During the next few moments, we will continue our search to understand both the mysteries of the universe and our significance within it, as we venture to the most distant corners of creation. And as we pause along the way to marvel at the celestial masterpiece the Creator has fashioned in the night sky, we will stand in a light more radiant than cast by any galaxy or star. The light of God's eternal power and truth, reflected in the miracle of all that He has made.
In all of history, this has to be the greatest time ever to be an astronomer, because the pace of discovery just keeps accelerating. The answers to so many questions we could have only dreamed of knowing in the past now actually seem within our reach. It's a tremendous challenge, because once you leave the solar system and head out into the realm of deep space, the concepts of distance, time, and quantity take on meanings that are almost impossible to grasp, at least in the context of everyday experience. You see, within our Sun's family of planets, we can usually count and measure using increments that are somewhat familiar. Thousands, millions, perhaps billions. But when you consider the universe as a whole, it's so large that you have to begin thinking in trillions, and then from there move on to numerical values that are even more inconceivable. And even amongst astronomers, we throw around these huge numbers as if we really understand them. Oftentimes, I'm not convinced we really do. I have to sit back from time to time and reflect upon what are these millions and billions and trillions and much bigger numbers that we throw around so easily. Now, to work with numbers that large requires a special unit of measurement. So astronomers have devised the light year. Simply put, it's the distance that light travels in 365 days. Think of it this way. We know that a beam of light moves at 186,000 miles per second. So in the course of a year, it'll travel about 6 trillion miles. At that rate, you could make a complete trip around the Earth in the length of time it takes to snap your fingers. Traveling that rapidly, a trip to the moon would take 1.3 seconds. You could reach the sun in about 8 minutes. And the nearest star outside the solar system, Alpha Centauri, would require a journey of a little over 4 years. Now, once you've established in your mind what a light year is, and again, it's the distance that light travels in 365 days, then you begin to realize what 100 light years must mean, or 1,000 light years, or 100,000 light years. And you would lose that entirely if you talked about miles in every one of those cases. Now, despite the enormous distances involved, technology has opened a spectacular window to the universe. And as we continually venture out, sometimes millions of light years from the Earth, we not only see many of creation's greatest wonders, we also have the chance to come face to face with the full magnitude of God's power. And it's an awesome sight.
Though its dimensions are enormous, our solar system actually measures about 1/1000th of a single light year in diameter, and is in reality only a pinpoint on one arm of the Milky Way galaxy. A cosmic ocean of perhaps 200 billion stars. To better understand just how large our galaxy really is, imagine the orbital pathways of the planets compressed into an area the size of a coffee cup. Within the parameters of this dramatically reduced scale, the Milky Way would still engulf the entire North American continent. Our solar system is located here, on the outskirts of the galaxy, about 25,000 light-years from its center. If we were to view the Milky Way on its edge, it would appear much like this. Its flat disk, measuring about 100 million light-years across, surrounds its bulging central core, a brilliantly luminous region containing more than 100 billion stars. Branching from this radiant hub, majestic arms comprised of gas, dust, and stars rotate like a carousel at speeds that can exceed 9,000 miles a minute. These arms are among the most beautiful of God's creations, and the location of mysterious and wondrous phenomena we are only beginning to understand. Scattered throughout the Milky Way, magnificent regions called nebulae move among the stars. These islands of hydrogen gas and dust, many of them thousands of times larger than our entire solar system, are illuminated by starlight, creating the most vibrant colors in the universe. Some of these nebulae, including the breathtaking Eagle, may possibly be stellar nurseries, locations where new stars are born. While others, like the Crab Nebula, are the products of an event that, though rarely observed, has captivated astronomers for centuries. In July of 1054 AD, Chinese astronomers first viewed and recorded the appearance of a spectacular new celestial body. They called it a guest star, and for 23 days it blazed as the brightest object in the heavens, except for the sun. Though they didn't realize it at the time, those ancient observers were witnesses to the violent death of a star more than 6,500 light-years away. now known as a supernova, the exploding star hurled gas, dust, and heavy elements in every direction while forming the ever-expanding nebula. Until 1968, an aura of mystery surrounded the cloud-like mass. Astronomers could not understand why, after 900 years, the remains of a dead star could continue to shine so brightly. Finally, the answer was uncovered at the National Radio Observatory in Green Bank, West Virginia. After aiming a powerful astronomical instrument at the center of the Crab Nebula, then tracking it as it moved through the heavens, radio frequencies not visible to optical telescopes were detected pulsing in a precise, consistent pattern. The source of these unusual transmissions would prove to be one of the most fascinating celestial bodies ever discovered. Following the explosion that had formed the nebula, remnants from the dead star compressed into a small, extremely dense object called a pulsar. Measuring less than 20 miles in diameter, the pulsar spun rapidly on its axis while generating an invisible shaft of ultraviolet energy that swept through space much like the beam from a lighthouse. These constant bursts of radiation have heated and illuminated the Crab Nebula for nearly 1,000 years. Shortly after its discovery, this sequence of photographs provided a direct view of the pulsar, flashing within the great cloud of gas and dust. Since 1968, radio telescopes have identified several hundred of these mysterious remnants of once massive stars throughout the Milky Way. The death of a star can produce another, even stranger phenomenon. When a star at least 5 times the size of the Sun finally burns out its fuel supply, it can collapse on itself, forming a black hole. The gravitational pull of this galactic whirlpool is so strong that everything around it, including light itself, is trapped inside. The shape of a star is distorted and stretched while being relentlessly consumed by the inescapable forces of a neighboring black hole. It has been speculated that the center of the Milky Way may contain a black hole with a mass and gravitational pull millions of times greater than our own Sun. Less than a century ago, it was commonly believed that the Milky Way was, in and of itself, the entire universe. Nothing was thought to exist beyond its boundaries. Then, in 1924, high above Los Angeles at the Mount Wilson Observatory, a discovery was made that would dramatically alter the world's perception of the cosmos. Utilizing the most powerful telescope of his day, the astronomer Edwin Hubble conclusively determined that distant hazy objects in space, long thought to be nebulae within the Milky Way, were in reality individual galaxies, many as large or larger than our own. For the first time in history, a correct conceptual view of the universe was in sight. Edwin Hubble had opened a window to a cosmos inconceivably large and filled with countless galaxies, richly diverse in their sizes and shapes. Elegant spirals, similar to the Milky Way, were discovered throughout the heavens. The graceful arms of these flat galactic pinwheels are formed of gas, dust, and billions of stars. Even more common are elliptical galaxies. Virtually devoid of gas, ellipticals are comprised almost exclusively of stars alone and are usually spherical or oblong in shape. While smaller, irregular galaxies take on a variety of eccentric forms. About 2% of all known galaxies are classified as irregular. Many of them are satellites of more massive spirals and ellipticals. Once thought to be evenly distributed throughout the universe, we now realize that individual galaxies are instead drawn together, at least in part by gravitational attraction, to form clusters and chains. It has been said that a penny held at arm's length toward the constellation Coma Berenices will block from view a cluster of more than 1,000 galaxies. Important clues to understanding the overall structure of the entire universe may well reside in these galactic clusters. And as astronomers continue to survey and map every corner of the cosmos, a remarkable tool of observation revolutionizes their quest for discovery: the orbiting Hubble Space Telescope. Named in honor of the renowned astronomer, the Hubble telescope captured the attention of the world during its spectacular repair mission in December of 1993.
Tally-ho on Hubble there, Houston. Houston, Endeavour has a firm handshake with Mr. Hubble's telescope. We're taking some great pictures with that.
A team of astronauts aboard the space shuttle Endeavour adjusted and fine-tuned the complex instrument while improving the focusing ability of its optical systems. Since then, the orbiting telescope has more than fulfilled the dreams of astronomers throughout the world.
Outstanding.
Working 300 miles above the haze of our planet's atmosphere, the telescope relies on the predictability and order of the universe to achieve its objectives. When a target area is identified in space, the Hubble's computers lock in on 2 of a possible 15 million predetermined guide stars. This procedure accurately aligns and maintains the position of the instrument as it continually moves around the Earth. The superb clarity and detail of the Hubble photographs have already established the telescope as one of the most significant astronomical tools of all time, reshaping our view of virtually every aspect of the cosmos. Hubble images of the M100 galaxy, 56 million light-years from the Earth, are enabling astronomers to accurately measure distances to stars that could provide vital clues toward computing the true size of the universe. The volatile star Eta Carina. Scientists now have a clear picture of a colossal eruption that ejected fragments of the star far into space at speeds exceeding 2 million miles an hour. With its cameras aimed at the nucleus of M51, the Whirlpool galaxy, this photograph of a mysterious silhouette on the galactic core is believed to be a direct glimpse of a massive black hole. After staring for 10 days at a small patch of sky near the handle of the Big Dipper, the Hubble generated one of the most spectacular pictures in the history of science. At least 1,500 galaxies, many only 1/4 billionth as bright as the dimmest light the human eye can see, were revealed in a single breathtaking panorama. Within a pinpoint of sky, the size of the area blocked by a grain of sand held at arm's length, the scope of galactic diversity and distribution was showcased as never before. At the very limits of the known universe, the Hubble telescope has photographed small, extremely bright galaxies that release incredible amounts of radiation. Quasi-stellar radio sources, or quasars. These distant objects, some 1,000 times brighter than the Milky Way, emit as much energy every second as our sun could radiate in 10 million years. The source of a quasar's power is still unknown, but a popular theory contends there is an enormous black hole in its nucleus. The quasar's gravitational field is strong enough to attract a neighboring galaxy, and in the process, it pulls off huge quantities of stars and gas. As the galaxies merge, the quasar converts its captured fuel supply into radiation strong enough to blaze from the deepest corners of known space. From the vantage point of a mountaintop observatory, the heavens are an open volume waiting to be read. And as a sky filled with individual wonders is surveyed each night, no aspect of the universe proves more striking to behold than its size. Throughout the Old Testament, a recurring phrase is used to describe God's shaping of the cosmos. He stretched out the heavens. Though written more than 3,000 years ago, the words convey a vivid and accurate picture of the universe modern astronomy continues to reveal. The sheer quantity of celestial bodies is almost beyond comprehension. Though estimates continue to rise, it is believed there are at least 100 billion individual galaxies in the universe, many of them comprised of 200 billion stars or more. In an effort to draw these numbers into some kind of meaningful focus, the British astronomer Sir James Jeans speculated that the total number of stars in space could equal or surpass the total number of grains of sand on all the seashores of all the world. And in most cases, each of these stars is separated from any other by trillions of miles. He stretched out the heavens indeed. But how large really is the universe? There is no way to measure precisely, but some perspective can be drawn by using the imagination to survey its boundaries of distance and time. Let us travel now at the speed of light, departing from our home star on a trip across the cosmos toward the edge of the known universe. Our imaginary journey begins at midnight on January 1st, when we prepare to launch into space at the speed of 186,000 miles per second. We quickly pass the orbits of Mercury, Venus, and span the 93 million miles that separate the Earth from the Sun in just 8 minutes 19 seconds. We continue on, passing Mars, then the gas giant planets, Jupiter, Saturn, Uranus, Neptune. Finally, after 5 hours and 31 minutes, we race past Pluto and its companion moon. Our journey has taken us more than 3.5 billion miles to the outer limits of our solar system. And it's still January 1st. Now we alter our flight path and travel in a direction perpendicular to our galaxy. Behind us, the 9 planets and the Sun quickly vanish from sight. The emptiness of space is broken only by the light of stars so distant they do not yet appear to move. A year passes, then 2 years, 3, 4 years. Finally, on April 19th of the 5th year, we reach Alpha Centauri, the nearest star to our solar system. We have traveled more than 25 trillion miles, and our journey has scarcely begun. We are now 10 light years from the Sun, far enough out in space that the stars within our galaxy appear to converge. 100 light-years from the Sun. Patterns of gas and nebulous material from the arms of the Milky Way fill our view. 1,000 light-years. The galaxy's arms and disk become more defined. Yet it is not until we have traveled at the speed of light for 100,000 years that the entire spiral shape of the Milky Way is recognizable. From here on, each point of light we see is no longer an individual star, but an entire galaxy composed of billions of stars. "5 million years after beginning our journey, the Milky Way is seen as part of a cluster of about 30 galaxies, known as the Local Group. "50 million light-years out, we encounter the large Virgo, containing more than 2,000 galaxies. And so it goes, as our travels continue to take us deeper into the cosmos. We pass cluster after galactic cluster, each a building block of a far greater framework. A billion years pass. 5 billion. Finally, after 10 billion years, we decelerate and pause to observe a theoretical view of the universe's large-scale structure. Countless billions of galaxies are now seen to comprise chains, masses, and thread-like structures that stretch across the cosmos, separated by enormous regions of empty space. It is a spectacular tapestry, so vast and diverse in its design that the power of its creator must truly surpass all human understanding.
From the perspective of size alone, I guess that you could say as human beings, we appear to be little more than microbes, living on a speck of cosmic dust we call the Earth. Here we have a universe that's so incredibly large, and we are incredibly small, so that relatively speaking, our place in the universe is totally insignificant. This was illustrated by the Voyager spacecraft several years ago. Millions of miles from Earth, Voyager 1 looked back and showed us our planet in a way we had never seen it before. It was just a tiny dot, engulfed by a single ray of sunlight. And when you look at the picture today, it's not hard to understand how the Old Testament writer David must have felt when he asked God, "How could man possibly be important to you?"
It is a question both timeless and quite logical. For when considered against the inconceivable power and size displayed throughout the universe, any perceptions of personal importance we may hold are easily overwhelmed. Yet God did not create on this awesome scale to frighten or intimidate us with His power. Instead, each night He uses the sheer magnitude of the cosmos to help reveal the enormous significance of every human life.
We're told in the book of Psalms, in the Old Testament, again of the Bible, that the heavens declare the glory of God. We're not told anywhere else that any other part of nature specifically does that as clearly as the heavens do. It's interesting to note that by definition, the very word cosmos means an object of superb craftsmanship or a system of order and harmony. Now that's a wonderful interpretation of exactly what the universe seems to be. God has revealed His creative juices, if you will, in the way that He's made diversity and beauty and wonder. And it's there getting our attention, saying, hey, I'm here, look, here's the evidence that I'm here. It's something that the Lord has put out there for each one of us to seek out and come to the conclusion that there must be a designer, there must be a creator. And so consequently, I think most astronomers I've ever met believe there is a God. We may differ in our opinions or understanding of just who God is and how involved He is with His creation. But the vast majority of astronomers, I do believe, recognize that there is a creator. But even though I've met very few atheist astronomers, I've come to realize that merely recognizing that God exists is only the first step toward really understanding Him.
As we look deeper and deeper into space, the size, splendor, and design we see throughout the universe tells us very clearly that there must be a creator. Yet to understand what that creator is really like, we must employ a different tool of exploration. Something that can extend our view beyond what we can learn about God from observing the physical aspects of His creation alone.
It's a difficult jump to make when you're going from the world of science, you're going to the world of thought, you're going to the world of physical evidence. You can test things in the laboratory or test ideas or theories. But then when you try to come down to the ultimate questions of the meaning of life and what our relationship is to God and what our responsibilities are, science has no answers for you there. You have to leave the realm of science and go into some other realm. Now we're talking about the spiritual realm. And our methodology there has to change, our tools have to change, because there's no way that our finite minds could ever accurately discern the true nature of an infinite God. To do that, we needed something beyond our own intellect or experience. So God revealed Himself to us in the form of His Word, the Bible.
Opening a Bible is an experience in some ways comparable to turning a telescope toward the night sky. For like a precisely crafted lens or mirror, the Bible clarifies and expands our understanding, not of planets and galaxies, but of the God who made them. Anyone who reads its pages can begin to discern the deepest feelings and thoughts of the Creator of the universe. And as we look beyond the realities of His unmistakable existence and power, we come face to face with a personal, loving God who reaches out to each of us with His promises of forgiveness, hope, and eternal life.
Come to me, all you who are weary and burdened, and I will give you rest. For I am the Lord your God, who says, do not fear, for I am with you. I will strengthen you and help you. Peace I leave with you. My peace I give to you. Do not let your hearts be troubled, and do not be afraid. In this world you will have trouble, but take heart. I have overcome the world. I have come into the world as a light, so that no one who believes in me should stay in darkness. Truly I say to you, he who believes in me has eternal life. Never will I leave you. Never will I forsake you. I have loved you with an everlasting love.
God loves us and cares about us very deeply. The Bible very clearly tells us that. And the more you learn about Him, the more you realize that here we have a God who's so big and so powerful that He created the universe beyond comprehension in size. But yet at the same time, we have a God that loves us so much and cares for us so much individually that He's promised to meet every need that we'll ever have. For some reason beyond my understanding, we're important to the Creator of the universe, and He loves us more than anything else He's ever made.
In all of creation, there can be no greater mystery or miracle. Though we inhabit a mere speck of a planet, we are the supreme focus of the Creator's attention and care. And as we explore God's celestial masterpiece during the decades to come, new discoveries will undoubtedly enhance our understanding. For we are privileged to see more clearly into space than ever before. And with every stunning glimpse, the universe will continue to reflect both the grandeur of God's creative power and the matchless significance we hold in His eyes.